going to provide the steps to import data from your Oculus Topographer to your EyeSpace software. We will also demonstrate the simplicity of designing an EyeSpace orthokeratology lens. Please join me in welcome Darren Nygren, President of Custom Craft Lens, the U.S. distributor for EyeSpace. He will be providing today's demonstration.
Thank you, Angela. Today we're going to start with the Oculus software and import an Oculus topography into the EyeSpace program. So first you'll select your patient. In this example we have patient Smith. Then we will load the topography that we're going to use for the lens design. Once you've selected this, you'll click the external software and then select EyeSpace. This will launch the software, which will then take you to this patient's file. To begin, we'll first select the topography, then we will select New Lens. Then there is a drop-down menu, and Forge is the Ortho-K product, Bespoke is the daily wear lens. So we're going to design a Forge Ortho-K lens. You will take the corneal diameter from your topographer and enter it in this field. Next, there's a drop-down menu and you'll select Spectacle RX. And then click Done. The software is currently designing a lens, importing the Oculus information, and this is the EyeSpace lens design software. So we'll break this down into 4 parts, and we'll start with the upper left-hand corner. You'll see it has your keratometry readings, then the amount of corneal cylinder, in this case is 1.1 diopter, the delta sag at a 9mm chord, and the HVID. The delta sag at a 9mm chord is elevation data measured at 2 points at a 9mm chord. The reason this information is important is this determines which zones need to be toric for your lens design. For example, you could have 2 patients that have the identical K readings. On one patient, the bow tie is limbus to limbus. On the other patient with the same K reading, it only goes out 6mm. So using this elevation data, the software will design the zones that need to be toric. In this case, it's the toric reverse curve and a toric alignment curve. So let's break down the different parameters that we see. We have the base curve optic zone radius. The Z zone is used to measure the elevation data, or also known as the sag value. So if you take the letter Z and break it down, from the bottom bar being the cornea and the top bar being the contact lens, the line connecting the two is the difference, or also known as the sag value. Put another way, we currently see 27 microns as central tear film thickness in the simulation in the lower right corner. So if we decrease this value by 10 from 255 to 245 and 275 to 265, it will reduce the central tear film thickness by 10 microns. Now we can see we went from 27 to 17, and the desired value for the central tear film is 15 to 20 microns. So this looks good. The next field is the alignment curve, which is the zone between the edge of the reverse curve and the beginning of the peripheral curve. It's aptly named the alignment curve, as its primary purpose is to center the lens on the cornea. The lens diameter, which is designed using the software based on the HVID that we entered when starting the lens. Down in the second row of parameters, you'll see the BOZD, the base curve optic zone diameter. The next field is BOZE, also known as the base curve optic zone eccentricity. This box will be used if we're designing a lens for myopia management or for presbyopic orthokeratology. The edge width, the width of the peripheral curve, and the edge radius. Some practitioners have a preference of how much clearance they like in the peripheral curve. So again, there's a direct correlation between this value and the tear thickness at the peripheral curve portion of the contact lens. The final field is the alignment curve eccentricity, which is used in advanced troubleshooting cases, oftentimes to improve centration. Once you've designed the lens and you're happy with the way it looks, you will select Add to Cart. If you had a left lens to design, you would go ahead and design the left lens and also add it to the cart. Then you will select Submit Order. You see here, this is the lens we just designed. There's a drop-down menu where you can select the material. If you do not change this, the software will default to Boston XO green for the right lens and Boston XO blue for the left lens. The next box is a note for communications to the lab or to the consultant. If you would like the lab consultant to review your lens design, or you would like to indicate the date the patient's scheduled for a dispense appointment, this information can be typed in this box and conveyed to the lab. And on the bottom of the screen, you'll see you have two options. You can click Review, which will upload the topography and the order to the cloud for laboratory consultation review. If you click Order, the lens will automatically go into manufacturing. That concludes this training.